So welcome back. So the suggestion is, well, what about using, if there's delta, the two things that are available to me would be to find my, I want to find the delta t, so I could try and find my, again I'm thinking vertically here, so I could try and find my VF, or I could try and find my displacement delta x. And the only thing about finding the displacement is that then I say, what equation do I use? And the one that springs to mind actually is delta x is equal to VI delta t plus 1/2 a delta t squared. And again, I need delta t with it. There's VF squared equals VI squared plus 2a delta x, but then I need VF anyway. VF equals VI plus AT. I don't know VF and I don't know T, so it doesn't move me on a bit. Again, this is just practice and experience. So what we find it a bit more useful is to say, okay, we're going to find VF. And the question then is, do I know it? I do, actually. Can anybody tell me what VF is? So, if you decide to end the journey at the top, then your VF is 0. The only problem with that is when you're at the top, you're there, and you're only halfway down your range. So if I decide that my VF is 0, I've got to remember that whatever time I get has to be doubled before it goes back in here. But that's people do that. The alternative is you let the entire journey play out, so you start and you end on the ground. And then the entire time is just the time you want for this entire journey. So when I first started, I would remember it was 0 at the top and then double my time, but sometimes I'd forget. And after a while, I just started saying, oh, I'll just remember. And what do we know about the vertical speeds at the same height in terms of the speed values? If I take any height, doesn't matter where it is. Well, they're both the same speed. One's going up and one's going down. So I know that VI is minus 16.077 meters per second. I know that. That's conceptual. Oh, not so bad then. So that means that I come along here and I say, well, VF equals VI plus A delta T. That's nice. So minus 16.07 equals plus 16.07 plus minus 10 times delta T. That's going to be minus 32.14 over minus 10 equals delta T. So delta T equals plus 3.214 seconds. So delta X is equal to 19.15 times 3.214 seconds. So I go 19.15 times 3.214. That's going to be 61.55.
I understand the rations and information you gave in the problem, but somehow they not satisfies me. Like, for example, if the cannonball is somewhere not on the ground, then the distance may be different.
Oh yeah, sure. Big different problem.
Yeah, but you didn't say any problem, right? Did you?
I say a cannonball is fired with muzzle speed, degrees elevation above the horizontal. What is the range? No, I agree. My language, I think because I was doing this in class, I didn't write it out like I would have done for an exam. And if you turned around to me and said, you know, hey, that's not clear enough, I'd look at it and go, yeah, I agree, and give you more information. If I said above a level field, then, or kicking a football on a level field, then, you know, unless I tell you there's a hill in the way or a hole in the way, it's a level field, you know. I'm not going to try and trick you like that. But yeah, I agree, that's just too few words in that one, yeah. It's a two-dimensional problem, though, isn't it? It's really, for the first time, it's a problem that we need to use both axes for. It's a two-step problem. Notice that I didn't try and remember it's a two-step problem. I tried to solve it in one step and found I couldn't. And then said, well, I need to find time. It told me, you need time to solve this problem. So I went to the other axis to find the time. So always try and solve your problems in one step. And then if you can't, it will tell you what you need to do. And the trick is you always go to some independent axis to get the information you don't have. Was there a question or a comment, Cohen?
Why didn't the acceleration affect the final velocity?
Where's my final velocity? Oh, you mean here?
Right.
It did. It took it from plus 16.0 seconds, 16 meters per second to 8 meters per second to 0 meters per second to minus 8 meters per second to minus 16. There's a difference of, it changed the velocity by 32 meters per second. It's just that the signs are, you know, it's like, you know, they're very different. One is in that direction and one is in that direction.
So this is the same concept as if I toss a ball up
Yeah.
and it goes.
Yeah, that's exactly right, yeah. So it's the same speed. It's not by chance because I'm taking the same level, they happen to have the same speed. But very different velocities, yeah. Yeah. Save the best for last. Right small on this one. Okay. So this is, a ball is kicked from the edge of a cliff. .12 meters per second at 4 degrees elevation above. So there's my... The cliff is 2 meters high. What is the ball's range? The range, of course, is the horizontal displacement. Try and solve in one step. Visualize. .19. If only I knew that delta t. Find delta t using vert inf. Visualize. Seven 7.71. We'll call it 7.7. A. I want to find my delta t. Got two choices, VF, or I can find delta x. Do I know either one of them? Delta x. I want you to write down, or mentally or on paper, what you think the value of delta x is from that diagram. Write it down. Commit to it. And the answer is -2. It has to be -2. Because there's the start of your vertical journey and there's the end. And that's a negative direction. And the problem is if you put down a +2, it thinks you mean up here. And it may well be that your object does go 2 meters above the cliff before it comes down. In which case, there'll be no warning. It will not blow up. The calculation will just proceed nicely. And you'll end up having the wrong answer. So, that attention to detail is really important. Then I say, well, now I have a math approach and a physics approach. Shouldn't really say that. It's like, but why not? The math approach. Delta x is equal to VI delta t plus 1/2 A delta t squared. So -2 is equal to VI 7.7 delta t plus 1/2 times -10 times delta t squared. So 5 delta t squared minus 7.7 delta t minus 2 equals 0. That's quadratic. You want to solve that. You say delta t is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And of course a is the first coefficient and b is the middle coefficient and c is the last coefficient. And if you put everything on the other side, everything would have the opposite sign, so the answer would work out to be the same. It doesn't matter, as long as you have everything on one side or the other. So we have minus 7.7 plus or minus the square root of 7.7 squared minus 4 times 5. A is not acceleration. A is the first coefficient. 4 times 5 times minus 2 all over 2 times A. So delta T is going to equal 7.7 plus or minus the square root of 7.7 squared, 59.3, minus and minus makes plus. That's going to be 5 fours are 20, 2 20s are 40. Can you see how if you'd have put in the positive 2, you would have had minus 40. So this would be the square root of 19.3, but still doable. As it is, it's positive 40, so it's the square root of 99.3. So I have second, well, let's write this out. 7.7 plus second square root of 99.3 is going to be 9.96. Call it 10 over 10. And I have, this also equals 7.7 minus 10 over 10, which equals 17.7, 1.7 seconds, and this equals minus 2.3, 0.23 seconds. Yes?
Didn't we have negative time?
So, good question. So the equation doesn't know when your clock starts or ends, it just knows the relationship between these things. So because I chose to start the clock when it was like coming off the cliff, it's also looking at that same height. It's looking at this value here, and it's saying, well, you cross here on the way down at that time, but by symmetry you're also crossing here on the way up at that time. So it's not that it physically doesn't mean anything, but mathematically it's valid, you know. But, you know, sometimes we can't just ignore it because it's a negative. Although we have to justify in our minds, you know, to ignore it. But we can. So then we say, aha, so final step. So this gives us, let's do it in a nice blue. So then we go, oh yeah, in that case then delta x is equal to plus 9.19 times 1.7. So delta x is equal to 9.19 times 1.7. I'm getting 15.6. Is there a 15.6 there? There's actually that's.
It's because you rounded earlier.
It's because I rounded earlier. It's, yeah, fair
That
enough.
was me, that.
If I didn't round, it would be 16.3. So 15.6, which kind of goes to. I wish I'd not done that. 16.3. I rounded too soon. Watch out for that. Truly a two-step problem. Yeah.
Where did you get 1.17? Why is it not 0.22 seconds?
Oh, because this is a negative. That's when the thing was kind of going like that on the way up. Yeah, so it's this one down there because it's a positive time.
How did you get that 15.6?
Pardon?
How did you get that 15.6?
I did 9.19 times 1.7. Did I make it work? Not work it out? 9.19 times 1.7. Because I rounded.
Oh, you rounded, okay.
Yeah, I rounded too soon. Yeah, I made that 9.9 into 10 and all. It's a whole bunch of things. Yeah. So a two-step problem, a true two-step problem with a little bit of math thrown in. It is about as long as it gets. Can I show you another way? Just to do the end bit? Because there's a physicsy type way to do the end bit. So can I erase? And then you'll see it. So we'll take out all that. Man, it's going to take me an age to get rid of all that. So if you turn around and say, man, I'm not going to do a quadratic. Then I say, well, that's great, but you've got to find another way of doing it. So what you say is, well, if these four require me to do the quadratic, then I am going to work out what my VF is. So I'm going to say, okay, well, what links these guys? VF squared equals VI squared plus 2a delta x. That will make me my VF, and then I'm going to use VF equals VI plus AT to get my time. So I'm going to say VF squared equals VI squared, which is 7.7 squared plus 2 times minus 10 times minus 2. So VF squared is equal to 7.7 squared, and that's 59.3 plus 40. So VF is equal to the square root of 99 point something, which we're going to call 10. And is the catch, what's wrong with that value? 59.3 plus 40 is 99.3. Square root of 99.3 is close enough to 10. What's wrong with that value? It's a minus, isn't it? That thing is that bit there, and it's going downwards. That V final is going downwards. So again, conceptually, you might miss it. And then you go, well, in that case then, minus 10 is equal to VI, 7.7, plus A, minus 10 times delta T. So delta T is equal to minus 17.7 over minus 10, which equals 1.77 seconds. And then I say, okay, delta X is equal to 9.19 times 1.77 seconds. 9.19 times 1.77 seconds equals 16.3. I think I must have made a mistake on that other one. I did something that was just not right. That's the physics way. It's a 3-step problem. After a while, you get to the stage where you can mean 7 steps. I don't care. It's just a lot of little things. How many people on the gut feeling say, I can do a quadratic equation. Why worry about this? I'm just going to do the quadratic. And how many people will say, man, why would I bother with the quadratic when I can do it doing the physics way? So decide. Oh, neither one. If you say, I don't want to do it either way. If you don't want to do it either way, it's not so good for the test, So one way or the other. But some semesters, everybody in the class will do it the quadratic way. And other semesters, everybody in the class will do it the other way. And sometimes it's a mix. It's kind of interesting. There's no better way. That's about as hard as it gets at this stage. That's about as hard as it gets. It's long. There's only so many scenarios I can throw at you. Didn't mean to do that. There's only so many scenarios I can throw at you. I can have you, yeah, we fire you like that. I can have you coming off sideways. I can have you firing up that way. I suppose I could have you firing down sideways. I can have you going like that. I can have you going like that. I can have you going like that. There's only so many things I can do. You're either going onto a maze, or you're going into a hole, or you're on the level. I suppose I could do that, but I've never done it. I wouldn't do it for you guys. There's no homework in it, but you could. I mean, it's like, it's kind of interesting that, because your displacement there would depend upon your displacement there. That would be a very interesting problem, actually. So that's the family. There will be a projectile motion problem on your test. It'll be test 2. There will be a projectile motion problem on. I can't imagine not giving one. So it's a skill, just learn the skill. We've got 10 minutes. I want to do a little bit more. Did we have a break yet?
No.
Let's call it a day there. Okay, because I'm done. I think you're done. Sorry. If I don't give you a break, feel free to kind of say, because so for next time we have a quiz next time, agreed? And what did we say was going to be on the quiz for next time? Prefixes, the geometry, and the 4 kinematic equations. That's for next time. So, and just easy points. Just